Hi everyone! Today we're continuing Module 5, so we're still in Chapter 7, and we're going to talk about molar mass. So last time we talked about the mole and how that's equal to Avogadro's number, or 6.02 times 10 to the 23rd. And that number can apply to anything that you're counting, but it most often applies to atoms, molecules, ions, etc. So in today's video, we're going to talk about the mass of an element, or the mass of a mole of an element. So for any element, the quantity called molar mass is the quantity in grams that equals the atomic mass of that element. So for example, 1 mole of sodium has a mass of 22.99 grams. So 1 mole of sodium is equal to 6.02 times 10 to the 23rd atoms. And all of that is also equal to 22.99 grams of sodium. And this is the number that you can find on the periodic table below the chemical or element symbol. So remember, a long time ago we talked about isotopes and how some elements have atoms with different numbers of neutrons. So when we look at the mass on the periodic table, that's an average mass of all of the isotopes of that element. And previously, we were using the unit atomic mass unit, but now we're going to look at grams and moles. So again, the molar mass is the mass of 1 mole of an element, and the atomic mass is expressed in grams instead of atomic mass units. So 1 atomic mass unit is equal to 1 gram per mole. So we can use those interchangeably. Now you might notice I left the E off of mole. That's just an abbreviation for mole, M-O-L. Apparently writing that E is too much of a bother, so we just abbreviate it as M-O-L. So you might see that occasionally. All right, so if we look on the periodic table, we can see the molar masses for different elements. So for instance, carbon has a mass of 12.01 grams per mole, and lithium has a mass of 6.941 grams per mole. And off to the sides, you can see one version of a conversion factor that you could use for these molar masses. So remember, you can also flip those conversion factors if you need to, depending on what you're solving for. All right, so again, this is true for all of the elements on the periodic table. They each have a molar mass. And if we're looking at carbon specifically, let's say we measure out exactly 12.01 grams of carbon. Now, that is equal to 1 mole of carbon. And in 1 mole, we also know that we have 6.02 times 10 to the 23rd atoms. So all of these different variables are related to each other: moles, mass, and atoms. So more visually, in this picture, we have 1 mole quantities of different substances. So 1 mole can look very different depending on what you're referencing. So for instance, sulfur has a mass of 32.07 grams for every mole. Iron has a mass of 55.85 grams per mole. And it almost looks like we have less iron here. But again, that has to do with the difference in mass. We still have a 1 mole quantity there. If we look at sodium chloride, that has a mass of 58.44 grams, and we'll talk about how to calculate a molar mass for a compound in a second. Now, once we get to these larger molecules like potassium dichromate and sucrose, which is table sugar, you can see 1 mole amounts are much larger because they have many more atoms per mole. All right, so let's practice. Let's calculate the molar mass of lithium carbonate. Lithium carbonate is actually used to treat bipolar disorder. So this is a very useful compound. So if we're going to calculate the molar mass for this compound, we first have to look up the masses of lithium, carbon, and oxygen. Those are the 3 elements that are in this compound. So down below, you can see the masses for each, and we just look these up on the periodic table. So lithium has a mass, or a molar mass, of 6.941 grams per mole. Carbon, we already said, has a mass of 12.01 grams per mole. And then oxygen has a molar mass of 16 grams per mole. Now, we also have to take into account that we have 2 lithium atoms, or 2 moles of lithium. We only have 1 carbon, and we have 3 oxygens. So we'll have to take that into account too. Okay, so what we do is we multiply those 2 moles of lithium by the molar mass, which again is 6.941 grams per mole. And you can see that moles of lithium will cancel. So really we're just multiplying 2 by the mass of lithium. And that will give us 13.88 grams of lithium. I don't know why the G's are so large there. I keep meaning to go and fix that, but I think it's a picture, so I can't change it, unfortunately. All right, so then for carbon, we only have 1 mole of carbon, and then we multiply it by the molar mass of carbon, so 12.01 grams per mole. And then moles will cancel, so we're just doing simple dimensional analysis here. And then we'll just end up with 12.01 grams of carbon. And then last but not least, we have 3 moles of oxygen, and we'll multiply that by the mass of oxygen, which is 16 grams per mole. Some periodic tables will list the mass of oxygen as 15.9999. That's okay. You can round it up to 16. It still works. So 3 times 16 gives us 48 grams of oxygen. So now we know how much mass each element is contributing to the overall mass of lithium carbonate. So the last step, we're going to take the sum of these masses. All right. So again, we're going to add 13.88 to 12.01 to 48, and that will give us the mass of 1 mole of lithium carbonate. So that mass is 73.89 grams. Now, what's great about that is we can turn that into a conversion factor. So let's say we were solving some problem where we needed the molar mass of lithium carbonate. We now know that there are 73.89 grams of lithium carbonate for every 1 mole of lithium carbonate. And we also know that 1 mole of lithium carbonate is equal to 6.02 times 10 to the 23rd molecules or compounds of lithium carbonate. We would probably actually use a term called formula unit. Ionic compounds we refer to as formula units, and then covalent compounds we refer to as molecules, but that's okay. For now, we'll just use the word molecule. So now we have all of these tools that we can use to figure out how much of something we have. And that's going to be really important when we start looking at reactions and how much of a product we expect to form. Let's do one more learning check. Let's calculate the molar mass of C2H6O, which is ethanol. And last time we talked about how ethanol is found in alcoholic beverages, but sometimes they can be composed of methanol, which is toxic to our systems. So if you want to pause the video and calculate the molar mass of ethanol, feel free, and then when you unpause, we'll go over it together. Okay, so let's go over this problem. So we have, it looks like 2 moles of carbon. We have 6 moles of hydrogen. Oh, moles. And then we have 1 mole of oxygen. Okay, so we already said that the molar mass of carbon is 12.01 grams for every 1 mole. Now, we haven't looked up the molar mass of hydrogen yet, but if you look on your periodic table, the number underneath the element symbol is 1.008, or some periodic tables will just round up to 1.01. It just kind of depends on the periodic table. And then that's for every 1 mole of hydrogen. And then we already saw that the mass of oxygen is 16 grams per mole. Okay, so let's go through and calculate each of these different factors. So for carbon, we have 2 times 12.01, and moles will cancel. So we get 24.02 grams of carbon. For hydrogen, moles will cancel. And 6 times 1.008, let's see, that gives us 6.04, I believe. Let's see, let me double check on my calculator. I was trying to do that in my head. Yeah, oh, 6.05, 48. So we'll just add an 8 in there. All right, and then for oxygen, moles will cancel, and we only have 1 mole of oxygen anyway, so this will just give us 16. Okay, so now we're going to add all of those together. So let's, I'm going to plug that into my calculator here. So we get 24.02 plus 6.048 plus 16. Okay, so that gives us 46.068 grams of C2H6O, and that is equal to the mass of 1 mole of C2H6O. Now let's talk about sig figs really quickly. So notice that our first mass ends in the hundredths place, our second mass ends in the thousandths place, and our third mass ends in the hundredths place. So going through, this is an addition problem, So we care about the number of decimal places, and we want to limit this to the fewest number of decimal places. So our answer should actually end in the hundredths place. So we could change this to 46.07 grams. Now, this can get tricky because some periodic tables will list 3 sig figs, some will list 4, some will list 5. Kind of depends on your periodic table. So I won't be too picky with sig figs for molar mass, but it's just something to be aware of. All right. So here are the solution slides. Okay, oops. So in the next video, we're going to go over calculations using molar mass. So remember, we can use molar mass as a conversion factor. So we'll just be doing some simple dimensional analysis. So I will see you then.